Hello, OChem 2. Welcome back. This is reaction 4 in a 5-part series. And these next two, I'm going to switch to mechanisms. So let's try and help us do some mechanisms for this next test. You're going to have a Blackboard portion. There won't really be mechanisms on there, but you'll have a take-home portion, and then you're going to have to draw some mechanisms. So let's look at this sample test question. And let's see if we can't figure out what kind of mechanism it is, what kind of reaction it is, and go from there. So the first thing I'm going to look at are my functional groups. I've got a ketone over here. I have an amine. Is that an amine? Oh, hang on a second. That is an enamine. Okay, that's telling us something. And over here, we've got a nice ketone. So this question is a little bit more complicated than just a mechanism. We have to figure out what that second component is. So when we did these in class, we did several mechanisms in class for our enamines coming from ketones. And one of the first things we looked at was double check your reaction conditions. These are all in equilibrium, and you have to figure out what direction you're going. So we have an acidic catalyst, awesome, and water. And remember, this is our key right here. This water is telling us that we are going in this direction. And why do we care? Remember, this also gives us our goals. So throughout our mechanism, our goals are going to come from the fact that we are going to add water and lose our amine. And our reaction equilibrium, we've set it up that way. So that's the point of our mechanism. All right, so let's see if we can figure out what kind of mechanism. Well, we've got an enamine, and we're going to a ketone. So we are going backwards, and we are going to add water, and we are going to lose an amine. Specifically here, we're going to end up losing a secondary amine. And how did I know that? Because the only way we can form an enamine is from a secondary amine. That is it. So we know we're going to have a ketone and a secondary amine. We've got to figure out which bonds we're going to make and break. So in other words, which part is the ketone and which part is the amine. So let's do some more highlighting here. How can you tell on this substrate which one is which? Well, obviously here's your nitrogen, but you've got 3 bonds there. So how do you know which ones you're aiming for? Well, what's awesome is that you have the answer right here with the enamine. The only way to make the enamine is from a beta hydrogen. So it's telling us that the actual iminium ion intermediate we're going to form is going to have to be this one, and the beta hydrogen we're eliminating is going to be this one. So then where is our actual amine? This one, and it's going to include all of that. And then this portion is our cyclohexanone. Okay, awesome. So let's start our mechanism. Let's take a second and erase some of this. And I never just start a mechanism. I always stop and figure out what kind of reaction is this? What kind of mechanism are we going for? And that's really key in all of OChem because our mechanisms are set. If we're giving a mechanism in class, it is not made up. That is coming from Mother Nature. That's coming from kinetics. Those are mechanistic studies that happen. It is not up to you to reinvent the wheel on that mechanism. That is the mechanism for the reaction. And it usually has a nice set of rules, and we always follow that set of rules for our mechanism. So let's start with that first step. And I'm going to cheat a little because I have limited space, and I'm going to use my starting drawing. All right, what is always our first step? If we have a lone pair and we have acid, that is our first step. But now enamines are tricky because you are going backwards and you don't have the imine already, but you need the iminium ion intermediate. So an enamine is not just a regular amine. That enamine is tied to that ene. That has to be in the first step. So out of this whole mechanism, this is the trickiest part. That lone pair is going to react with your acid, but it is going to react through the alkene. So what does that make? Let's see if we can't draw that whole structure. Okay. I'm going to color code as usual for my electrons so that we can really tell where everything is coming from. Okay. All right, so what did we just do? We just did that, put a charge on nitrogen, and we just reacted with the hydrogen in our acid right there, and then we just lost our leaving group from our acid, that conjugate base right there. We just lost that. Okay. All right, so now what do we do with this? Well, in class, we labeled substrates like this with that charge. We labeled this iminium ion as activated. Remember, we have to activate that double bond. If you're going to react there, this is making this carbon right here a super electrophile. Why is that important? Because what we're about to add there, water, is kind of a crappy nucleophile. So you just made your electrophile even better. All right, so let's take water and let's react it right there. Lone pair on water are the nucleophile. So now we're going to go like that. Okay. Let's draw this whole beast again. My drawings aren't as nice as they are on the board. I'm still getting used to this pen, but trying. Okay, so we still, where did these electrons end up? They are now the lone pair on nitrogen, and we just added that water in and have a charge. Okay, hold on a second. What did we just make? This is awesome. We always pause here. We just made our tetrahedral intermediate. This is where we just refresh. Hey, let's talk about our goals. Let's talk about our feelings. All right, out of this intermediate, your best leaving group is right here. You don't want your water to leave. Remember, our goals are to add water and lose our amine. So, right now we cannot let that be. We have got to manipulate charges. Now, it seems really enticing. I know even on one of my answer keys, you just want to take this nitrogen lone pair so bad and just take one of those hydrogens, but that's really pretty much cheating. That's not going to happen all in one step. That is that is always something that happens separate. So first of all, let's get rid of this charge on oxygen. Okay, we've got several things in our system that can take that. You know, eventually we'll have an amine there. That would be the best base. Or we've got a ton of water or a Cl minus. Just for funsies, I'll go ahead and use water. Okay, so now what did we just make? I'm going to have to, I guess, go... I'm going to have to go all the way over here. And remember, these are in equilibrium. Okay, so let's go all the way over here. I'm going to try and draw just slightly smaller. Oops, too many carbons there. Okay, and then we still have our lone pair here. We have this time just OH here, and we got this lone pair back on water. Okay, still have a tetrahedral intermediate. We still have our goals. Right now our leaving groups we're favoring nitrogen, but nitrogen as a negative in an acidic solution. You're just not going to have that as a leaving group. So let's make that even better. Remember, you now have a nitrogen in acid. So let's protonate that. All right, give me a second to draw this huge structure again. I guess that's the downfall of putting a bunch of rings on your structure, is that then you run out of screen space. Okay, so now we just protonated that nitrogen. So now if you take a look at it, holy cow, that is an awesome leaving group now. Look at that nice acidic nitrogen there. So now in organic 2, we don't just spontaneously lose a leaving group. You help it. You push that leaving group off. Now we're back to business. What did we just make here? Now we're getting pretty close to the end. Now you can see our ketone. And then let's scroll up a little bit and let's write what happened to our amine. What did we actually make here? We've got a benzene on one side. We've got a nice cyclohexane on the other. We've got a hydrogen and our lone pair. So this is our secondary amine. That was that other question mark in the question. And then the only thing we have left to do is to get rid of this charge on our ketone. And then this would be the end of our mechanism. Isn't that awesome? All right, so definitely I hope you tried this before you let me give the answer to that. And this first part, that is the tricky part. For an enamine, you have to protonate the actual enamine, not just the nitrogen, not just the amine. That is how you get your activated aminium ion. All right, I hope this is helpful. I've got one more to do, so I'm going to go ahead and post this one and then do the next question. I hope